As introduced there, my name is Fionn Griffin. I'm a chemist working for ESB. I'm in the power generation side of the business, so I'm in the section that basically owns the power stations, runs the power stations that produce electricity. Just my own background, I'm a chemist. So I did after my leaving cert, I did a degree in UCC in chemistry, and after that then I did a PhD in UCD in nanotechnology. And after that then I joined the ESB, and I'm there with them since. So just a bit of background to the ESB. ESB is a semi-state, so it's not owned 95, pretty much 100% by the government. We were founded in 1927, and the first power station we built was this one you see here in the picture. It was a hydro power station, which basically produces electricity from water. So at the top end of the screen there, you see the sort of head of water flows down through those 4 tubes in the power station, spins a turbine and makes electricity. At the time in 1927, that was enough to power the whole country, that one power station. Now it represents about 2% of our current electricity demand. Currently, we're at the peak of the demand. We use about 4,500 megawatts of electricity. So if you imagine a 100 watt light bulb, that's equivalent to 4.5 million light bulbs being used in electricity every day in Ireland. We've an annual turnover of about 3 billion, and basically 1 billion of that is reinvested every year. So in big capital projects, so reinvesting in the networks, upgrading power stations, doing maintenance and overhauls and things like that. So today we have, in Ireland, we have seven power stations. We have coal power station in Moneypoint and Clare. We have a number of gas power stations. We used to have oil stations as well, so they burnt oil as a fuel to make the electricity. We don't have them anymore. We've 10 hydro stations dotted around the country. We have a few here in Dublin on the Liffey. We have a few in Shannon, a few in Cork, a few up in Donegal. We also, probably what a lot of people wouldn't know, is we have a lot of power stations abroad, so we have an international arm. And with that, in that international section, we own power stations in England, Spain, Malaysia, and as far afield as Pakistan. So, you know, ESB isn't strictly an Irish company. So joining the ESB, you can get to see the world as well. So I'm a chemist within the ESB, but also within the ESB that we hire an awful lot of engineers. So in every power station, we'd have a number of engineers. Every power station would have a chemist as well, and I'm actually based centrally in Dublin. So what I do is I'm sort of look after all the power stations in the country, so I get to go out and visit power stations and do work in the various power stations. That's a snapshot there of a few of the power stations. So on the top left is a gas-fired power station in Cork. The top right is Moneypoint down in County Clare, so that burns coal. So a big ship comes in, docks beside that jetty out in the sea, unloads the coal into the coal yard, fed into the furnace to make electricity. The one on the bottom left there is an interesting one. That's a hydro power station, and the way that works is you can see 2 lakes there on the picture. So there's a top lake and a bottom lake. The top lake is an artificial lake, so that was built by us. And what happens is you pump water from the lower lake up into the top lake. So when you want a sudden increase in the amount of electricity produced, you can open a gate and flood the water down back into the bottom lake, and that will produce your electricity. We also own a number of wind turbines, so again we have a lot of engineers employed in building and maintaining wind turbines. Believe it or not, there's 25% of Ireland's peak demand can be produced from wind at the moment. So on the right there you have a graph of energy production. So this was taken from 27, so the day before yesterday. There was about 1,000 megawatts of wind on the system. So out of 4.5 gigawatts, 1 gigawatt of that was being produced by wind. So there's a lot of CO2 emissions being saved by making these wind turbines. The only problem with it is that this is the forecast for today. So today's a non-windy day. So your electricity generation from wind is down close to 0 on a day like today when there's no wind. So wind is great, but it's up and down. So every day there's a different amount of it produced. My own role as a chemist in the ESB, I'm in the power generation side of things. So basically our power stations work by taking in cold water down there at the bottom in the condenser. You put it into the furnace, and you add coal or gas or oil into the furnace. You light a big fire. The cold water gets heated up, gets slowly converted into steam. Steam passes into a turbine. The turbine spins, which spins a generator, which makes electricity. The temperature inside in those furnaces is about 1200 degrees Celsius, so it's extremely hot in there. And as a consequence of that, we're producing very hot steam. We're producing steam at about 450 degrees. and very high pressure steam, and as a consequence of that you need ultra pure water. So just as an example there of how pure and where the role of chemistry comes into it is I've taken Ballygowan water versus what we use in our power plant. So Ballygowan kind of is sold as pure, natural and mineral water, but pure is it's all relative. So Ballygowan, that's the actual specification of Ballygowan on the back of their bottle. They've 15 parts per million of sodium in the water. So out of every 1 million molecules of water, 15 of them are sodium. If we were to use that water in our power stations, the place would fall apart after a couple of years, because to us that water is impure. It's fine to drink, but in a power station with very high temperatures and very high pressures, it just wouldn't work. So we treat our water in a water treatment plant to produce ultra pure water. So where Ballygowan would have 15 parts per million of sodium in the water, we'd be down at 0.002 parts per million. So this water is so pure that you actually can't drink it. If you drank it, I don't know if you know Lucozade Sport is isotonic. If you drank this water, it would actually start pulling salts out of your body into your stomach, and you'd basically dehydrate, and it wouldn't be good for you. But for the power station, because it producing water and steam at such high temperatures and pressures, that's what we need to maintain the power station. So that's where the role of chemistry comes in. So at various parts in that cycle, this is kind of an example of my role within the company. So I'd be looking at the power stations, the various different power stations around the country, looking at how pure their water is behaving, how pure their steam is. If it's outside of specification, then we need to take actions to bring it back into specification. All along the cycle we have a lot of instrumentation, taking water samples out of the power plant, measuring things like sodium, measuring things like pH, the amount of ammonia in the water. These are all very important. So I've a system like this where I can see all the power stations. I'm based in Dublin here, but I can see all the power stations at my desk in Dublin, and I can see a system like this where I can see Hada down in Cork is producing 408 megawatts of electricity, and there I can see how pure the water is at various stages in the cycle. So I know if everything's green, it's within specification. If anything is red, it's out of specification. So my job is sort of a troubleshooter. If something goes wrong, I have to go down to the power station and try and fix it and get everything working back properly. So there you can see that this power station just started up there. So you can see this couple of items still out of specification. They're highlighted in red. So that's where the role of chemistry comes into generating electricity. As I said, every station would have a chemist, would have a couple of chemists in them, and then we'd have a couple of chemists as well based in the head office looking at these things centrally. Also, corrosion is a big feature in power stations. So corrosion is a chemical feature as well. So basically the power stations rust over time if they're not maintained properly. So you see a boiler tube there that's rusting away pretty badly. And as part of my job, I'd be looking at the materials in the boiler tubes, looking at how well they're behaving looking at the water going into them, and looking at corrosion properties, seeing if a boiler tube fails, looking at what caused it, what were the chemical parameters that caused the failure. So there as well you see a microstructure of a cross-section of a boiler tube. So if you cut a slice of metal, looked at it under a microscope, that's what it would look like. That's a corrosion one. So you see there the surface is very irregular at the top where it's all dark. All those shiny bits of grey should all be nice and tight on the metal surface. Because it's rusting, they're pulling away from the surface, and that's going to reduce the lifetime of the power station. So if a failure happens in a power station, part of my job is to go and investigate the failure and identify the reasons for it and try and prevent it happening again. As part of that, I use the facilities here in Cran. So I'd use the electron microscope here in Cran to look at high-powered images of the metals and do elemental identification, so see if there's any chlorine there or sulfur or any of the other elements that would cause corrosion. Also, I do a lot of testing in the power station, so we run a lot of projects. One I was involved in recently was burning biomass. So we have a couple of peat-fired power stations that basically burn turf in the power stations, and we're looking at substituting that for biomass. So we looked at burning wood chip, which is basically chopped up trees. Willow, which is kind of a tree as well, but it's more like kind of a bamboo type of tree. Chopping that up and burning it in the power station. That's a picture of it there on the top with the digger loading it into a truck. And also miscanthus, which is a tall grass that grows to about 2 meters tall. And again, we chop it up. So the whole aim of this was reducing CO2 emissions. See, can we reduce CO2 emissions in our power stations by burning miscanthus or willow or wood chip? So part of those tests, there's a lot of chemistry involved in those tests. We'll be looking at the flue gas, so see how the gas going up the stack changes. We'll be looking at fuel composition, so we'll be looking at the energy content of the fuel, the sulphur, the ash, the moisture, and see how basically see how well the fuel burns, see if we get the same energy out of it at the end of the day, see if we can produce the same quality steams and so on at the end of the day, and also see what's going up the chimney, so see if anything happens to the composition of the CO2 and SO2 and everything going up the chimney. This is a few pictures of the test programs. On the top there is the emissions testing. So we'd hook that up to the chimney and pull out a sample of gas and see what's in the gas. We'd be looking at moisture, dust, SO2, NOx, and every station is allowed to emit a certain amount of gases under a license issued by the Environmental Protection Agency. So we'd have to make sure that the gases we are emitting if we burn biomass aren't any different from the ones we're emitting from burning peat, or even better than the ones we're emitting burning peat. We'd also look at chemical additives and combustion processes, so we'd look at the impact of adding coal ash into combustion, so you could try and reduce corrosion effects. And again, also looking at emissions up the chimney as well at the same time, so see how the impact on emissions to atmosphere. That's a brief summary. So as I said, there are chemists in the ESB. When I saw the job, I was wondering what does ESB need a chemist for? They just produce electricity, but there's a lot going on behind the production of electricity. That there's a heavy engineering role in the company, there's a heavy chemistry role in the company, and I suppose we're always looking for people with sort of specialist qualifications that can help do these kind of projects, build these power stations, and sort of install infrastructure and try to fix problems when they happen. So engineering and science for us are important parts of the company. Any questions?